In the topic of temperature, what we will learn is the definition of temperature and also how to measure temperature. And when we talk about measuring temperature, we will talk about the different types of thermometers as well as the different types of temperature scales. So let's talk about the definition of temperature. Now, the temperature is defined as this here, property of an object that determines which way heat will flow between it and another object. So why do we define temperature in this way? It's because imagine if you had a pen in your hand at 26 degrees Celsius and you bring it to the seaside where the temperature is 24 degrees Celsius. Now, if you were to consider the temperature only, then you will see that the temperature of the pen is actually higher than the temperature of the ocean. However, if you consider the amount of heat contained in the pen and you compare the amount of heat contained in the entire ocean, definitely the ocean contains much more heat. Yet, when you put this pen into the ocean, heat will still transfer from the pen to the ocean. So meaning to say, heat will always transfer from higher temperature to lower temperature, regardless of the amount of heat. It also means that temperature does not necessarily measure the amount of heat contained in a body. So if we look at another example here, where you have two objects x and y placed together, you will see that x is a higher temperature than y. So when you place them together, there will be net heat transfer from x to y. As heat is transferred from x to y, the temperature of x will drop, the temperature of y will increase. And this will keep happening until they reach the same temperature. And when they reach the same temperature, we say that these two objects are in thermal equilibrium. So thermal equilibrium occurs when both bodies have the same temperature and there's no net heat transfer between them. So why do they use the word net heat transfer rather than just heat transfer? It is because heat flow is a dynamic process. Even at thermal equilibrium, heat flow doesn't actually stop. What happens actually in the beginning, the rate of heat flow from x to y is actually higher than the heat flow from y to x. So we will say there's a net heat flow from x to y. As the temperature of x drops and the temperature of y increases, the net heat flow from x to y decreases. And when they reach thermal equilibrium, the rate of heat flow from x to y is equal to the rate of heat flow from y to x. And that is when we say they reach thermal equilibrium. So why is it important to learn about thermal equilibrium? It is because most of the thermometers that we use, especially in the labs, are actually based on this concept, which is thermal equilibrium. For example, if you are familiar with the mercury in glass thermometer, which is actually a type of liquid in glass thermometer. So what happens is, if you put the thermometer into a beaker of hot water, we have to stir and wait for a while. The reason being, we are waiting for the thermometer to achieve thermal equilibrium with the beaker of water. And when they reach thermal equilibrium and you pull out the thermometer, what we are actually reading is the temperature of the thermometer. And since the thermometer is in thermal equilibrium with the beaker of water, we can therefore conclude that is the temperature of the water. So other types of thermometers that we will explore in this chapter will be the resistance thermometer, which makes use of resistance of a thermistor that will vary significantly with changes in temperature. And then we will also talk about the gas thermometer, which will use the pressure of a gas to measure temperature, because the pressure of a gas will vary linearly with temperature as well. And the last type of thermometer we're going to explore will be the thermocouple thermometer, which makes use of the voltage that's generated between two terminals of the thermometer. Now, all these properties that we use, physical properties that we use to measure temperature, for example, the length of mercury, the resistance of thermistor, pressure of a gas, or the voltage of a thermocouple thermometer. All these are what we call as thermometric properties. So what is the definition of a thermometric property? A physical property that varies significantly with temperature. So therefore, our thermometer must make use of a thermometric property, which is a physical property that varies significantly with temperature in order to measure temperature. We also use the concept of thermal equilibrium in order for the thermometer to work. So the things that we shall consider in this chapter as we attempt more partial questions or even tutorial questions is what are the differences between the different types of thermometers. And one of the differences that we can observe between the thermometers is in relation to the heat capacity. Now, heat capacity, by definition, is the amount of heat energy needed per unit temperature rise. Now, we will learn more in detail in the next chapter, but in the meantime, it is good enough to understand heat capacity as being the amount of heat that the thermometer has to absorb in order to cause its temperature to change by 1 Kelvin. So if we consider that all the thermometers that we are going to talk about relies on thermal equilibrium, which means to say, if let's say your thermometer that we are going to use is at 24 degrees Celsius, for example, okay, and if we place it in a beaker of hot water of, let's say, 50 degrees Celsius. So when you put the thermometer into the beaker of water, as the heat transfers from the water to the thermometer, its temperature, which is the temperature of the water, will start to drop, and the temperature of the thermometer will increase. And this process, this heat flow, the net heat flow, will become a zero when both the beaker of water and the thermometer reach thermal equilibrium, which means to say when they reach thermal equilibrium, the temperature of the water can no longer stay at 50, it would have most likely dropped. So the bigger the heat capacity of the thermometer, the bigger the temperature drop, which would mean the temperature that we are measuring using the thermometer is no longer accurate, because by using a thermometer, you have actually caused cooling of the liquid. So these are the things that we will be considering as we do more and more questions. So now let's look at how to establish a temperature scale. Now, there are many types of temperature scales that we use. I think the most familiar ones would be like Celsius, Kelvin, Fahrenheit, and even for some of you, you may even have heard of the term centigrade. So what are the differences between these temperature scales, and how do we establish them? So let's look at an example. Let's say you went to the pharmacy to get a thermometer. Okay, so you bought a mercury glass thermometer to measure your body temperature. So upon reaching home, you realize that while the thermometer is not faulty and is still functioning, they have actually forgotten to label the scales on the thermometer. So there are no scales. So the question is, how are you going to calibrate this thermometer to enable it to measure temperature? So if you were to think about it carefully, most of the students would give me this answer. They would say they will place it in a beaker of ice, which is called melting ice. Okay, and they will put the thermometer in and see how long it is. And what they will do is let's say they mark the point as 0. And then they will say, they will place it in a beaker of boiling water, all right, boiling water, and observe how long is the length of the mercury inside the thermometer. And once they know how long it is, they will mark as 100 degrees Celsius. Now, after that, they will say they're going to divide these 2 points here with 200 equal intervals. So if you were to calibrate your thermometer this way, you actually cannot call your temperature in degrees Celsius. Rather, you should be calling it in degrees centigrade, because what you have just described is how to calibrate a temperature scale in degrees centigrade, because there was a scientist named Centigrade, and this was how he calibrated his thermometer. So for a centigrade scale, the rule is you will have to choose two fixed points, which will be ice point and steam point. And ice point, you're going to call it as 0, and steam point, you're going to give it as 100. And then you're going to divide to 100 equal intervals. Now, when you divide to 100 equal intervals, do you realize that you're making a very important assumption, which is that the length of the mercury is proportional to the temperature? So the question is it true? Now, as we continue with this chapter, we will realize that this assumption is wrong. However, for the purpose of calculating temperature on a centigrade scale, we will assume this to be true. So, therefore, do remember, if you are choosing your ice point and labeling it as 0, steam point labeling it as 100, then you have actually chosen the centigrade scale. Now, centigrade scale is a type of empirical scale. Now, empirical scale means the scale that is obtained via experiment. So that means you put it in ice, you see how long; you put it in steam, you see how long is the mercury. So all this is by experiment. Now, for some people, they will still be confused, because whenever they see the symbol degrees C, for them it means degrees Celsius. But here we are calling it degrees centigrade. So if you really want to know what's the difference between degrees centigrade and degrees Celsius, you have to wait until the end of the chapter, where we will talk about the differences between both these scales. Right, so if you were to calibrate your thermometer using other fixed points, then you will be able to call it a different name. For example, in the Fahrenheit scale, they actually use different fixed points than the centigrade scale. They actually use one of the fixed points as the body temperature, and then the other one will be the temperature of brine, which is salt water. So therefore, they use different fixed points, we call it, and they also assign different values, and so therefore you will notice that 1 degrees centigrade is not actually equivalent to 1 Fahrenheit. So these are all examples of empirical scales. Later on in this chapter, we are also going to learn about the absolute thermodynamic scale. So for the absolute thermodynamic scale, then we won't call it empirical anymore. Alright, so let's move on. So if you wanted to calculate the temperature using the centigrade scale, but you didn't want to make markings onto the thermometer, because it's a little bit hard to do. It's actually quite hard to mark on the thermometer and then dividing to 100 equal intervals. All these are very tedious. There's actually a shorter way to calculate temperature, which is actually required for you to know. So there's a formula to calculate temperature on the empirical centigrade scale. Now remember, I was telling you one of the important assumptions in the empirical centigrade scale is that you're assuming, in this case, the length of mercury is proportional to the temperature. So generally, if you are also going to consider other types of thermometers, we're going to say that the magnitude of the thermometric property is proportional to the temperature. Okay, so this is an assumption. So meaning to say, if you draw two lines, one here and another one here, and you mark the points onto the lines. So for example, at 0 degrees, you put the thermometer at 0 degrees, you see the magnitude of thermometric property. Then you put the thermometer in steam, and then you then you measure the magnitude of thermometric property. Then you put it in the unknown temperature, and then you measure the magnitude of thermometric property. So do you realize, because they're proportional, that means this x is proportional to the theta, we can therefore say this difference over this must be equals to this difference over this, okay, which is what we wrote here. So t minus 0 over 100 minus 0 is equals to xt minus xi over xs minus xi. And therefore, if we eliminate the 0 and bring the 100 over, we will get this formula, which is the temperature in degrees centigrade. So do remember this formula where we can use it in most thermometers that make use of the empirical centigrade scale.